Dear children, let's study Charles' law now. Charles' law is the volume-temperature relationship. How volume and temperature of gases are related. We know that volume of gases are directly proportional to temperature. When temperature increases, volume of the gases also increases. And on cooling, volume of the gases decreases. This relationship was given by Charles, and the Charles law states that at a constant pressure, for a fixed amount of gas, fixed amount of gas means fixed number of moles constant. Amount of gas, when we express in terms of number of moles, fixed amount of gas means number of moles remain constant, number of moles denoted by the letter N. So at constant pressure, for a fixed amount of gas, volume vary directly with the temperature. That is, volume of a fixed amount of gas vary directly with the temperature at constant pressure. Charles law. If you replace this proportionality by equality, there comes a constant K2 into T. There K2 is the proportionality constant. If you rearrange this equation, V by T is equal to K2. That is, V by 2 is a constant. If you have a gas at volume V1 at a temperature T1, when the temperature is increased to T2, volume also increases to V2. According to, this can be written in terms of, on the basis of Charles' law, we can write this as V1 by T1 equal to V2 by T2. This will be a constant. So in this equation, if three quantities is given, that the fourth one can be calculated. Charles' law can also be represented graphically. If you plot volume against temperature, in temperature axis, if this is the 0 degrees Celsius, temperature in degrees Celsius, if I plot it as 0, minus 100, minus 200, minus 300, etc. We can take straight line graph here. Straight line graph will be obtained when you plot volume against temperature at a constant pressure. At constant pressure and a constant number of mole, volume vary directly with the temperature. When you extrapolate this graph towards the temperature axis, it would touch the temperature axis. When you extrapolate this graph towards the temperature axis, it would touch the temperature axis at a point, this point, corresponding to a temperature of negative 273.15 degrees Celsius. At this temperature, what will be the volume of the gas? Volume of the gas corresponds to 0. At this temperature, volume of the gas becomes 0. That means gas will not exist at this temperature. So this is a hypothetical temperature, lowest hypothetical or imaginary temperature at which gases does not exist, is called absolute zero. This temperature is called absolute zero. So what is absolute zero? At this temperature, gases does not exist. Before reaching this temperature, gases will be liquefied. And this temperature is negative 273.15 degrees Celsius. This is the lowest hypothetical temperature at which volume of the gas is 0. Means at which gases will not exist. Before reaching this temperature, gases will be liquefied. This temperature is called absolute zero. And this temperature, volume versus temperature graph plotted at constant pressure is called isobar. Isobars are constant pressure graph. Graphs plotted at a constant pressure is also known as isobar. So this is an isobar because the pressure is constant.